So this slide was asking you to sort, I think there were 6 cards, and it was asking you to sort whether or not you thought it was a physical change or a chemical change. So remember, when we're talking about a physical change, what we mean is that it's changing like the state of matter. So it may be changing from a solid to a liquid or a liquid to a gas. A chemical change means I'm actually changing the arrangement of the particles themselves or the molecule itself. So I'm changing my actual substance that I have. So I have kind of separated a few of them. I kind of hand drew them because I couldn't move them in this PDF, but hopefully you can kind of tell what I'm talking about. So I have right here, these are my physical ones, physical change. And the reason I chose these as a physical change is because, to me, this right here, these are really close together, so that could be a solid. And then these are farther apart, so that could be a liquid and maybe even moving towards a gas. So I'm not really changing my molecule itself. I still have the same molecule, right? I have this round molecule, I have this one and this one. I'm just changing their spacing or how close they are together. And it's kind of the same thing here. Like here, they're really close together, whereas here, they're a little bit further apart. So I'm not actually changing this actual structure or the atoms that make up the molecule. So that's a physical change. Down here, though, you can kind of see the difference. For my chemical change, I am actually changing the molecule itself. So this one, it's like it's getting broken right here in the middle. Where this bond is, I'm separating that molecule. Same thing here. I'm separating this molecule in half. So what I end with is not the same as what I'm starting with. Okay. Really, what's happening when we have a physical or a chemical change is we're really just affecting interactions between molecules, or within molecules. So when we have a physical change, we are affecting or breaking these interactions between the molecules. So it's not inside the molecule, it's just between two or more molecules. We call the attraction between those molecules intermolecular forces or intermolecular attractions. Okay, intermolecular. That's just between molecules. Okay, down here with my chemical change, though, these attractions for this bond, this bond, or the force of this bond that's holding these atoms together to make this molecule, they have a different name. We call those intramolecular forces. Okay, so intra. This means these are the forces within a molecule. Okay, so you do need to know the difference between those two terms. So if you're looking at the notes we're doing in class, there's a space for you to define those. So we also want to think about this in terms of energy required to do this. Remember, we mentioned when we talked about our heating curve, and we talked about the phase change that occurs right between solids and liquids and gases. If I'm melting a substance, that means that during that phase change, or when my line is flat, I think I can just kind of come down here and use this blank space. So here's my heating curve, right? So right here, where I'm melting, remember we said that this line is flat because It's actually using the energy to break apart those molecules or to overcome those attractions between molecules. Well, what we're saying is that it's using that energy to overcome intermolecular forces or attractions. Okay, so there are these forces kind of holding these molecules together here. And if I want to change the phase or the state of matter, it requires energy to kind of force those apart. Okay, so think to yourself quickly, which one do you think requires more energy? Do you think it requires more energy to separate like a whole molecule, so to overcome those forces between molecules? Or do you think it requires more energy to overcome those forces within a molecule? So if you guessed, let's change my color here. If you guessed down here, right, you would be surprised. So more energy needed. Okay. Which kind of makes sense if you think about it, because if I'm just melting ice, right, I still have water. It's not really taking a whole lot of work or energy to change that. I just leave a piece of ice out on the counter. It's eventually going to melt and change phase, right? Those molecules are eventually going to kind of start separating and turn into a liquid, okay? Just by the heat energy, the thermal energy. Okay. If I want to cause a chemical reaction, though, remember a lot of times, like, that means I have to burn something, right? Like light a piece of paper on fire if I want to chemically change that substance. So if I want to overcome those forces within a molecule, it's going to require a lot more energy. For example, our butane molecules, if I want to separate right here, it only requires 4 kilojoules per mole. If I want to separate right here, it requires 400 kilojoules per mole. Mole just means like a certain number of particles, like a unit. So I can see this requires almost about 100 times more energy needed for my intramolecular forces. Okay, so these are much stronger of a force. I suggest that you answer I think there's 5 questions on the notes that are posted on Schoology that we do in class. It's kind of a summary questions, just kind of thinking back to some of the things that we talked about, specifically looking at some of these intermolecular, intramolecular forces and differentiating between them. When you were done with that, there is an little exit activity. It's a Padlet, so you can just scan the QR code or click the link on Schoology. You're just going to write a 1-sentence summary of the essential question. And the essential question is posted on the notes, but it is, how can you use models to represent atoms, molecules, and particles? So, in other words, what purpose does that model serve? So, what could I use a model for as like a practical purpose? Okay. So, you're going to write basically kind of like an answer to the question, like a summary. We used models of atoms, molecules, and particles multiple times in this lesson to show different things occurring. So you could use one of those as an example or summarize several different ones. The last sentence is going to be just kind of a reflection of the notes. Did you find something interesting? Did you learn something new? Did you realize that maybe you already knew something, but you just didn't know what it was called? Did you learn something that you maybe thought you knew, but you really didn't know it? Maybe it changed your mind or clarified a misconception. So complete the Padlet when you get done with this. And then that is all for today.